Okay, so we're going to jump into question number 7. We're given the standard enthalpy of combustion for ethene gas, and we need to calculate the enthalpy of formation for the ethene gas. I've got the combustion reaction written there. Hopefully you remember how to write combustion reactions. I would guess that on a public exam that the combustion reaction would be given for you, but I can't guarantee that. Notice that the formation of water, we use the liquid state because this is the standard enthalpy of combustion, so we have all of our compounds at their standard states at room temperature, and we'll have a discussion about why exactly that is just a little bit later. So we've got our big giant formula that we get from the back of the periodic table. So let's plug in some numbers. We have negative 1411.1 kilojoules per mole is equal to, we have 2 times negative 393.5 kilojoules per mole, and 2 times negative 285.8 kilojoules per mole. And because we have oxygen as an element, we don't have to worry about that enthalpy of formation because it's 0 kilojoules per mole, and we only have one ethane. So we have 1 times the delta H of formation of C2H4. And I think this is the first time we can fit all of this onto one line. So we have negative 1411.1 kilojoules per mole. And here we have 2 times 393.5, which is negative, plus 2 times 285.8, also a negative, gives us negative 1358.6 kilojoules per mole. And we're going to subtract the delta H of formation of C2H4. Now it might look like I've gained a significant digit, and I guess I have. When we look at the 2 times 393.5, that is greater than, that's less than 1,000, so we get to keep our 4 significant digits. And our 2 times 285 is also less than 1,000, so we get to keep our 4 significant digits. But more importantly, we get to keep our tenths. And when we add two numbers where the tenths are significant in both of them, our final answer, the tenths, is also going to be significant. So we end up with an extra significant digit. Okay. Now, I'm going to move the 1358.6 kilojoules per mole to the other side. You might have a different choice with your algebra. That's entirely fine as long as you do it correctly. So I'm going to add that to 1411.1, and I'm going to end up with negative 52.5 kilojoules per mole is equal to the negative enthalpy of formation of C2H4, which of course means that the enthalpy of formation of C2H4 is positive 52.5 kilojoules per mole.